Hi and welcome to Jared's Academy. Today's lesson is about implicit differentiation. Implicit differentiation is another rule to determine an expression for slope of a tangent, but using chain rule. And the reason we're using implicit differentiation because we have y to the power of higher than 1. Here's an example of implicit differentiation. If I have y to the power of 2 plus 3x equal to 16, just for example. And our goal is to find y prime by itself, an expression for slope of a tangent. In order to do that, I see we have no longer y just to the power of 1. If I were to have y to the power of 1, for example, if I have y equals 2x, to find the derivative of y respect to x, I would simply go y prime equals 2. Now we have y to the power of higher than 1, so in this case to the power of 2, so we apply chain rule from outside to inside. What I mean by chain rule, what I mean is I'm going to rewrite this as y to the power of 2 and plus 3x equals 16. Now you can see that what I mean by chain rule from outside to inside. So we take the derivative of the from outside would be 2 times 1, which is 2, and y would be to the power of 1. Now the derivative of the inside of y, which is y, multiplies by the outside of the bracket, which is y prime. This is how we get y prime by itself. And then continue finishing the rest would be plus 3 equals to 0, because the derivative of 3x is 3, and the derivative of the constant is 0. Now the goal is to get y prime by itself. Now to get y prime by itself, we bring the positive 3 the other side of the equation, and then we divide both sides by 2y to get an expression for slope of a tangent. So negative 3 divided by 2y, and that's an expression for slope of a tangent. Now let's do another example to clarify implicit differentiation, and this example will have a combination of power, product, and chain rule. And here it is. For example, if I have x squared plus 3xy plus y to the power of 2 equal to 10, just for example. Now we're going to apply, to find dy by dx or y prime, here we're going to apply power rule, here we're going to apply product and chain. So the derivative of x squared would be 2x plus. Now here I'm going to apply power rule because we have two different relation and multiplication form. Let x be f and let y be g. And the product rule says the derivative of the first one multiplies by the second one plus the derivative of the second relation multiplies by the first relation, which is f prime g plus g prime f. And leave the coefficient outside for now, and then we're going to multiply everything by 3. So I'm going to leave the 3 out and I'm going to open big bracket. So the derivative of x, we said 1. 1 times y would be y, applying product rule. Now plus the derivative of y is y prime times x. Big bracket close, it's done. Plus now we apply chain rule here because we have y to the power of 2. So it would be from outside to inside. So the derivative of y squared would be 2 times 1 is 2. Subtract 1 from 2 be to the power of 1, so y to the power of 1 times the derivative of y would be y prime and equals to the derivative of constant as 0. Now we're going to do, in order to get y prime by itself, slowly, step by step, first we got to expand the bracket, multiplying by 3 outside the bracket by 3. So we have 2x plus 3 times y would be 3y. Plus 3y prime x plus 2y y prime equals to 0. Now, the next step would be leaving all the y primes on the left side and bring everything else to the right side. So we leave 3y prime x plus 2y y prime on the left side, and we're going to bring 2x and 3y to the right side. So we have negative 2x minus 3y. Now here, to get y prime by itself, I see a common factor. Y prime carries in both terms, so we take a common factor of y prime. We left with 3x plus 2y, bracket close, equal to negative 2x minus 3y. Now at the end, to get y prime by itself, we divide both sides by 3x plus 2y. So y prime would equal to negative 2x minus 3y divided by 3x plus 2y. Now, this is an expression for slope of a tangent. That's getting y prime by itself, or dy by dx by itself. Now, if you were to given a point for x and y to find the exact value of the slope of a tangent, you simply go ahead and substitute for x and y, top and bottom of this equation, and then you should be able to find the slope of a tangent to the curve. Sounds good? I hope this lesson or a few examples was very useful. Please do practice the same example that I've done here a few times till you understand the steps and the concept of this implicit differentiation. Then you can apply it to any given question from your textbook in order to do well, right? So please do not forget to subscribe. And if you have any questions, please leave it in the comment box. I should be able to reply back. Otherwise, I wish you all the best and good luck to yourself.